Here we have this example x prime equal to a times x, a 2, 4 minus 1 minus 2. You need to find the general solution of this equation. So the first thing you need to find the eigenvalues. A minus lambda I, determinant of that. Minus 1 minus 2 minus lambda. So we have 2 minus lambda and 2 plus lambda. So lambda minus 2, lambda plus 2. Minus is plus 4. So in this case we have lambda square minus 4 plus 4. So lambda square is equal to 0 if and only if lambda equal to 0. This is multiplicity 2. So we have the repeated eigenvalues 0. So for this eigenvalue 0, we compute the eigenvectors. The eigenvectors a minus lambda I v equal to 0. In our case, lambda is 0, so just a v equal to 0. A is this matrix. Let's say v now vectors in R2, say AB 0, 0. So we do row reduction of the coefficient matrix. The first row is minus 2 times the second row. So that matrix A, the coefficient matrix, is row equivalent to 1, 2, 0, 0. We would have let me use AB for this. A 2B 0. A equal to minus 2B. AB minus 2B B. B minus 1, so minus 2, 1. So an eigenvectors V equals V minus 2, 1. So we only have one eigenvectors, linear independent, multiplicity 2, but we found one. So that's 0 is defective. We now find the generalized eigenvector. So the generalized eigenvectors is the one, let's say V2. V2 is independent from V. Linearly independent from V. And A minus lambda I, in our case, lambda is 0. Square V2 is 0. And if you do this, you know that this one will give us 0 matrix. So V2 can be chosen to be anything linear independent from V. So we choose V2 to be 1, 0. Now for V2, we construct V1. v1 is a minus 0 I v2. A is this matrix minus 0 I, so this itself times v2 1 0. This is the first column. 2 minus 1. We have v1, we have v2. Now we construct the solution. f1 t v1 e lambda 1t lambda t, in our case lambda 0. v1 is 2 minus 1. f2 t is v1 t plus v2 e lambda t. So remember that this one prime is actually v1. In our case v1 2 minus 1 and 2t minus 1t plus v2. What is v2? 1 0 1 0. So this is this vector e lambda t. Lambda is 0, so it multiplies 1. So we have f2. The general solution xt is c1 f1 plus c2 f2. So c1 times 2 minus 1 plus c2 times f2. Yeah. So that's it. That is a general solution. So in general, the formula of that with v1 v2 in general is would be xt f1 c1 f1 plus c2 f2 c1 v1 e to 0, so times 1, c2 v2 times 1, c2 times this one, c2 v1t plus v2. So we can write as c1 v1 c2 v1t c2 v2. These two are just two vectors, doesn't depend, they don't depend on t. The only thing dependent on t is this term. So we know that first of all that is parallel, xt will be parallel to vector v1. xt parallel to vector v1. In our case, xt is parallel to vectors v1 v1 2 minus 1 is come from here, 2 minus 1. So let's draw it. x1 x2 1 2 minus 1. This vector, this is the eigenspace. v1 equal to 2 minus 1. So you see that if C2 is 0, the solution is just a point depending on C. It's just somewhere there, a point here, there, a point on this line. And otherwise it is parallel. If it's not on the line here, not the point on the line, then it will be parallel to that. The only thing we need to check is which direction. Is this go like this, or is go up, go down or go up. Now vector v1 is vector 2 minus 1. Vector 2 minus 1, v1 in this direction. This is vector v1. So this line will separate the plane. You can think of that as a median strip. Median strip. One lane will say move one direction, the other side will be opposite. So check that is on 0. So at the point, say at 1, 0, the direction x prime equal to ax. One, 0, b 2 minus 1, 2 minus 1, so it is parallel to v1 going like this. That is to say that it will be parallel to the right one and passing through this. So let me copy this. So that is what happened in this side. Then this side it go like this. The other side just go opposite. Let me get a few of the so this all go like this on one side. The other sides go the opposite direction. Still parallel to v1. Let's say the other lane colored by the green. So that is